In section 3.3, we're going to talk about derivatives of exponential and log functions. And by far the most common base you're going to get with your exponential functions is an e. And it's actually a very nice derivative because if I do the derivative of e to the x, it is actually just e to the x. So e to the x is its own derivative. If you have something more complicated than just an x as your exponent, so if it's some function of x, then what I do is I write down exactly what I have here. So I write down e to the u as is, and then I multiply times the derivative of the exponent. So u is my exponent, so I just multiply by its derivative. So in this first question right here, I'm given a function and just applying that rule. So I write down exactly what I see. So my y prime is going to be 2e to the negative 4x. And then I have to do the chain part of this, which is to multiply times the derivative of the exponent. In this case, the derivative of negative 4x, which is just negative 4. And that is the derivative. If I wanted to simplify this a bit, I can multiply the 2 and the negative 4, and I could handle this negative exponent by taking this e part and putting it in the denominator. And this is my final simplified answer. In question 2, I see I have a function inside of another function. So that means I have to use the chain rule. So this e to the 5x is inside of this sine function. So I'm going to go ahead and use the chain rule, and I'm going to define u and y first. So u is my inner function, and y is doing 3 times the sine of that u. And now I do each derivative. My exponential derivative is I write down exactly what I see. So e to the 5x times the derivative of the exponent, which is times the 5. And the derivative of 3 sine u is 3 cosine u. And what I do is I multiply these guys together. And that puts me here. And my last move is to get this in terms of x. So I need to replace that u and get it back in terms of x. And there's not much I can do to that as far as simplifying, so that is just my answer. In question 3, I've got x squared times e to the negative 2x. So my multiplication there requires a product rule. So this is my first, and e to the negative 2x is my second, and I'm going to run through the product rule. Here is my first function as is, times derivative of the second. So now I apply that exponential derivative rule, which is write down what you see, that's the e to the negative 2x, times derivative of the exponent, which is why this negative 2 is here, plus, and then the back half of my product rule is the second function as is, unchanged, times the derivative of the first, and my derivative of x squared is the 2x. As far as the derivative goes, that's all there is to it. If I want to simplify, what I see is I have 2 terms. Here is my first term. Here is my second term. And I see that they have some things in common. So they both have a 2. So I'm going to factor out a 2. And they both have an e to the negative 2x. So I'm going to factor that out. And they also have an x term. So I'm going to factor out an x. This is what I'm going to factor out of each one. So when I factor it out of this first term, the 2 looks like the negative is left and an x is left. This e to the negative 2x is pulled to the outside. So I have just a negative x. And then I've got my plus sign here. And in that second term, it looks like everything was factored out. So that just leaves a 1. And this is my final simplified derivative. In question 4, I've got a function, it's an exponential function, but it does not have a base of e like the other ones did. So I'm going to use a different formula for this, and it's written up here on the right side. So this is for when my base is an a, and a is just a number, a constant. So in that example I'm working on, it is a 2. And the formula looks like this. This is the one that has the chain rule embedded in it. So whatever your function is, you write it exactly as is, and then you do the natural log of the base, so natural log of a, and then I multiply times the derivative of the exponent. So I look at the exponent and I multiply times its derivative. So let's see how that applies on question number 4. Let's start by listing out what all these variables are. So my a is the base, which is the 2, so a is 2. U is my exponent, which is a 3x. I'm also going to need u prime, which is the derivative of 3x, which is just 3. And now I pretty much just plug into that formula. So my y prime is going to be a to u. In other words, just write this thing as is, times the natural log of a, and my a is a 2, and then times u prime, which is a 3. And there's not much cleanup that happens with this one, so I'm just going to leave it just like that. Question 5 is going to have a quotient rule, because I see f of x is defined as a quotient. And after I find f prime, I'm going to have to substitute in a 2. So I'm going to evaluate it, add an x value of 2. So let me start by finding f prime of x using the quotient rule. And here it is. So it's the bottom times derivative of the top, and that derivative of the numerator is 4x, minus the top function as is times derivative of the bottom. That exponential derivative is, you write exactly what you see. So here's the e to the 3x times derivative of the exponent, and the derivative of 3x is just 3, all over that bottom function squared. And now if I'm asked to do f prime of 2, I'm going to plug the 2 in. I don't have to algebraically simplify this first. I can plug the 2 in at any moment. So all of my x's over here, I'm going to substitute in a 2. Coming over here, I just replace the x with 2, and I end it up here. And I'm just going to simplify this a little bit. This is 8e to the 6th minus the 8 times the 4 is the 24e to the 6th. And here I have a power to a power, so I multiply those exponents. And I see in my numerator I have like terms, so I'm going to combine those next. And now when I have the same base, I'm going to subtract those exponents. So my final simplified answer is negative 16 over e to the 6th. Question number 6 wants me to write an equation of a tangent line, and for that I need a point and I need a slope. And what I have going for me is the x-coordinate of my point, and to find my y-coordinate I plug it into f of x. And here is my initial input, and all I did to get that was to take my negative natural log of 2 and plug it in for that x right there. Now you're going to see some log properties come into play in the simplifying of this. So I'm going to first take my 2 and make it the exponent of my argument. So that 2 is going to swing up and become an exponent. And just be a little careful here, because I see this e to the natural log and I know they're inverses, but I have to handle that negative first. So before I apply that inverse property, I'm going to take this and handle that negative exponent by putting it below the 8. And now I can see that this is going to give me a value of 4. And 8 divided by 4 is 2. And 2 plus 1 is going to be 3. So the point I'm going to use in my equation is natural log of 2, 3. And for my slope, I know I'm going to need a derivative. So I'm going to find f prime of x. So this is an exponential function, so I write down exactly what I see, and then multiply times the derivative of the exponent. And the derivative of 1 is just 0, so this is 16e to the 2x. And I want to know what that slope is at an x value of negative natural log of 2, so I find f prime of negative ln 2. And again, this is going to have me use some of those logarithm properties. I'm going to take the 2 and make it the exponent of this 2 over here. I'm going to take that negative and push that part below the 16. I recognize e to the natural log of 4 is just being equal to 4, and 16 divided by 4 is going to be 4, and that gives me the slope that I'm going to use for my equation. So I have negative natural log of 2, 3 is my point, and 4 is my slope, and then I just write my equation from there. As far as evaluating what natural log of 2 is, it is some decimally number that you don't need to worry about, so you would just present your answer exactly like this one. On page 2, we have natural log derivatives, and the natural log is more popular than any other base. That means we have a base of e, so when you see ln, that is a log with a base of e, and the derivative of the natural log is just 1 over x, If you have something more complicated than an x, then the chain rule is embedded in this one. So you write 1 over the u times the derivative of u. Another way of looking at that is just to simply call that u prime divided by u. And over here you have some natural log values that show up at various points in the course, so those are worth it for you to memorize. On question number 7, I'm asked to do the derivative of 5 times the natural log of 2x. So just applying this rule, it says to do 1 over that argument times its derivative. Recall that multiple constant, that 5 just goes along for the ride. And I do 1 over the 2x times the derivative of 2x. And all that's left is to simplify. And what I can see is my 2's will cancel out. And my final answer here will just be 5 over x. Number 8 is pretty similar. I have a natural log. So to find y prime, I'm just going to identify what I'm taking the natural log of. And I'm going to go 1 over this x cubed times the derivative of x cubed. And the calculus is done at this moment. All I have left to do is simplify. And an x squared on top and an x cubed on the bottom will leave an x in the denominator. And my final simplified answer is 54 over x. In question number 9, I see the telltale sign of a product rule because I have a product. This will be my first function, and natural log of x squared plus 5x will be my second function, and I'm just going to run through the product rule. Here is my first times derivative of the second plus the second function as is, and then times derivative of 7x, which is 7. As far as simplifying, there's not much I can do to pretty that thing up, so I'm just going to leave it exactly as is. Question number 10 has a base other than an e, so my base here is a 3. So I have a different formula to use for that one. And again, it's not very common. You probably will not encounter this on an AP exam. And once you identify what your a and your u are in your original problem, you just follow what this formula says right here. So in my question number 10, I can see that my a value is 3. And my u is sine x. And the formula also has a u prime, so I can go ahead and find u prime. And we know derivative of sine x is just cosine x. And once you have all this laid out, all we really need to do is plug into that formula above. And after that initial substitution, I'm sitting right here, and I can simplify this a little bit. So I'm going to go ahead and put that cosine over the sine x natural log of 3. And then we recognize cosine x over sine x as cotangent x. And here's my final simplified derivative. Our last question is another equation of a tangent line. So again, a point and a slope is what I'm after initially. The x-coordinate for my point is -2, and to find my y-coordinate, I just plug a -2 into my y equals equation. And that gives me 3 natural log of 3. And then I can take that 3 out in front. It becomes the exponent of the natural log of 3, and that becomes a 27. So my y-coordinate is natural log of 27. And I know for my slope I need my derivative, so I'm going to find y prime. And this is a natural log derivative, so it is 1 over the argument times the derivative of the argument. That's 1 over 1 minus x times the derivative of 1 minus x, which is the -1. And I want that slope at an x value of -2, so I need to take my -2 and plug it in. And when I do that and simplify, I get that my slope is -1. So my point is 2, natural log of 27. My slope is -1, and from that I write my tangent line equation. And that gives me y minus natural log of 27 equals -1 times the quantity x plus 2. And as far as that natural log of 27 goes, nobody knows what that value is, so you leave it as is. And just a recap of this lesson, the most important parts were the formulas that you see on the left side. So you'll definitely want to make sure that you are good with this natural log formula. This guy over here shows up a lot. And with the exponentials, the one where the base is an e, over on the left side. This is what you want to make sure that you're good on over here.